In this example, we're going to find the dimensions of a vegetable garden that has a fixed perimeter of 14 meters so that the area is as large as possible. So since we know that we have a fixed perimeter and we're trying to find out the largest area, we know that the shape has to be a square and all four sides are going to be equal. So there's our square. And we know that in this situation we're given that the total perimeter around the outside has to be 14 meters. And we're required to find out the length of the sides of this vegetable garden. Our formula for perimeter of a square is all four sides added up, which we can simplify to be 4s, 4 times the side length. And we'll substitute in the value that we were given in the question. So we had a perimeter of 14 meters, and we're subbing that in for p in our formula. We're going to go ahead and solve this now. So we've got 4s equal to 14. We need to try and isolate or get that s all by itself. To do that, we need to divide by the number or the coefficient in front of the letter. So the number in front here is 4, and we're going to divide both sides by that value 4. When we do that, we get 14 divided by 4 on the right-hand side, which gives us the decimal 3.5 meters. So we know that the dimensions of this largest garden is going to be when the side lengths are 3.5 by 3.5 meters. In previous activities, you've determined the dimensions of a rectangle with a fixed perimeter that give a maximum area, and you've also done the dimensions of a rectangle with a given area that have a minimum perimeter. These are examples of optimization, determining the best or optimal outcome for a given situation. When you've got a rectangle with 4 sides, the dimensions that give the maximum area or minimum perimeter are when the rectangle is a square or as close to a square as possible. So let's look at fixed perimeters. Let's suppose we have a rectangular swimming area at a local beach enclosed by a rope. The shore will be on one side of the swimming area, so only 3 sides need to be roped off. What are the dimensions of the largest swimming area if you only have 120 meters of rope? Will a square provide the largest swimming area, or is another shape, another rectangle, better? We're going to sketch some rectangles to represent swimming areas of various dimensions. Let's consider a swimming area that's long and narrow. In this case, we have one that's 110 meters long and 5 meters wide. The area in this case, if we do length times width, is going to be 110 times 5, giving an area of 550 meters squared. Let's consider a swimming area that's square. So if it's 40 by 40, it's going to give an area of length times width of 40 by 40, which is 1600 meters squared. The square swimming area certainly looks like it provides a large swimming area, but we're going to need to take a look at a few more shapes, a few more different situations before making our decision. For this activity, we're going to complete the following table to determine the dimensions of the maximum swimming area. So we've fixed a whole bunch of widths here, 5, 10, 20, 30, 40, 50, and 60 meters. We're going to determine the lengths for each of these, the perimeter, keeping in mind that the perimeter is going to be 2 of the widths plus only 1 length. Remember that the other length is made up by the shoreline. And then you're going to calculate the area for each of the possibilities. You can see that the first 2 that we went through a moment ago are already done. When we had a width of 5 and a length of 110, you can see that it gives our maximum perimeter of 120. Given the size of the rope that we had in the question, and the area then would be 5 times 110, which gives 550 meters squared. When we had a width of 40 meters and a length of 40 meters, we had the square. Again, it gave us 120 for our rope, and when you multiplied those two values together for the area, it gave us 1600 meters squared. So continue this table, completing the lengths. That would give a maximum value of 120 for the number of meters of rope, and then calculate the area for each of those cases.